So those powers of 10s with the negative numbers are kind of hard to look at, right? You really have to stop and think, and it's easy to make mistakes, and it's just kind of messy. So a different scale was developed to measure acidity and basicity instead of using 10 to the minus 7, 10 to the minus 12, etc. So it's a logarithmic scale. And so pH, let's just define what that is first. Well, here it is. pH is the negative logarithm of the hydronium ion concentration. And I'll get back to that. When the pH of a solution is equal to 7, we have a neutral solution. If the pH is less than 7, it's acidic. pH is greater than 7, it's basic. And so we can illustrate this here. We tend to use red to symbolize acid and blue to symbolize bases because bases turn litmus paper blue and acids turn litmus paper red. Here in the middle you've got neutral, and here the pH is going up, meaning that the concentration of hydronium is going down. So 1 unit on the pH scale corresponds to a factor of 10. So if the pH of this solution is 4, then the hydronium ion concentration is 10 to the minus 4. Because the pH is equal to the negative base 10 log of the hydronium ion concentration. So that's equal to the negative log of 10 to the minus 4. The logarithm is, the base 10 logarithm is the exponent on the 10. 10 raised to what power? So here the logarithm of 10 to the minus 4 would be negative 4. And the negative in front changes it to a positive number. So pH of 4 means the hydronium ion concentration is 10 to the minus 4. So here we have this one circle representing 10 to the minus 4 moles per liter of hydronium ion concentration. A pH of 3 means that the hydronium ion concentration is 10 to the minus 3rd. So now we have 10 circles. The concentration has increased by a factor of 10 for this 1 unit change on the pH scale. If we go from pH 3 to pH 2, now the concentration increases to 10 to the minus 2. So we've got this times 10, and now we have 100 little circles. So it's a logarithmic scale, like the Richter scale that measures earthquakes is logarithmic. So if you're going from a 6 to a 7, that's 10 times stronger. Okay, so pH is equal to the negative log of the hydronium ion concentration. And the note to myself here is, explain logarithms. You may not remember, but you did learn about logarithms at some point in your life. So, oops, that's not what I wanted to do. Get lost. Okay, I'm going the wrong way. There, okay. Sorry about that. Okay, so the log of 10 to the 2 is equal to 2. The log of 10 to the 5 is equal to 5. So the log of 10 raised to a factor is the factor. So when we're dealing with just powers of 10, logarithms are very easy. You don't even need to use a calculator. If I take the log of 10 to the negative 7, that's going to be negative 7. So the concentration of hydronium ion in a neutral solution is 1 times 10 to the minus 7. So if I took the log of that, that would be equal to -7. But negative numbers get kind of confusing. They're kind of messy, right? So we're making the scale into a positive scale. It has its own problems, but it's what they did. So if I want to make that into a positive number, I'm going to multiply both sides by -1. Negative log is just the logarithm of that number, change the sign. And this is called pH. So P stands for negative log of, and the H stands for the hydronium ion, or the hydrogen ion. What if I have a different kind of a number? What if I have, 3.7 times 10 to the minus 4? What's the log of that? Well, I have to use my calculator for that. So depending on how your calculator works, you may need to put the number in first and then press the log button, LOG, or you may need to press the log button first and then put in the number. On my 36X Pro, I press the log button twice because the first time gets me natural log, the second time gets me base 10 log, LOG, and then I put the number in 3.7 times 10 to the negative 4, and I press equals, and I get negative 3.43. Let's just put some extra digits on there, 1/8. So if this is x, that's log of x. So what if I want to find the log of 3.7 times 10 to the negative 6? That's going to be minus 5.4318. Do it on your calculator. 3.7 times 10 to the negative 14. Negative 13.4318. No, I don't have the log tables memorized. Did I do this right? I know I did. There's a pattern here. What do these three numbers have in common? What's the same about them? The 3.7 part, right? They're all 3.7 times 10 to the something. What's the same about these three numbers? The digits after the decimal place. They're all 0.4318. What's different about them is the value of the exponent. And what's different here is the value of the number before the decimal point. This 3 is because of the 4. This 5 is because of the 6. The 13 is because of the 14. This takes the place of the exponent, the placeholder. These are the significant digits. These are the significant digits. So these numbers actually only have the 4 and the 3 as their significant figures. So this part, because these numbers are less than 1, this ends up being 1 less than the exponent. If you understand logarithms, they are really, really cool. I don't know that I really understood logarithms until I started teaching pH, and then I kind of had to figure them out so I could explain them to somebody else. But just so you know, significant figures with logarithms, if you have a number like this and you look at the number of significant figures, I've got 2 significant figures. When I take the logarithm of that, or I make it into a pH, only the digits after the decimal point are significant figures. The number before the decimal point comes from this exponent, which was not a significant figure. It's placeholder zeros. Any questions? What you need to know how to do is do negative log on your calculator, okay? You don't have to understand logarithms as long as you can just, do the trick. So we should be able to calculate the pH for each of these. So pH is equal to negative log of the hydronium ion concentration. They gave us the hydronium ion concentration. So it's the negative log of 9.5 times 10 to the minus 9. I can tell you that's going to be 8 point something. So on my calculator, I press the negative sign, not the subtracting sign, but the negative sign. And then I press the log button twice, so I get LOG, and then I type in the number 9.5 EE minus 9, and I press equals, and it tells me 8.02 is the pH. This negative does not mean anti-log. It just means change the sign. Make it into a positive number. You getting your calculator to do that? Okay. If you're not, you need to come see me in lab because we have to do this calculation in lab. And so you come and ask me to talk to your calculator. It's your calculator's fault. It's not you. It's your calculator. I know how to threaten them so they'll behave. That's one answer, the pH. Is it acidic or basic? Basic. It's basic. So you can do that. You can answer that by looking at the hydronium ion concentration or by looking at the pH. If the pH is above 7, it's basic. The hydronium ion concentration is below 10 to the minus 7, it's basic. So this is basic. So let's do the pH for this one. So negative base 10 log of 6.1 EE minus 3. pH is 2.21. Acidic or basic? Acidic. It's less than 7. Acidic means the pH is less than 7. Basic is when the pH is greater than 7. Your book talks about strongly basic, weakly basic. I don't care. Just acidic or basic is good enough. Neutral is pH 7, or very close to it. Questions? If your calculator isn't behaving, please talk to me during lab today. Well, what if we're given the pH and we need the hydronium ion concentration? I'll go through this very quickly because I know most of you probably don't care, but some of you might. So we've got that equation, and I'll give that to you on the exam. pH is the negative log of the hydronium ion concentration. Rearranging this is a little more complicated than like one of the gas laws or something. So I want to move the negative sign, so I'm going to multiply both sides by -1. That makes that positive and this negative. To get rid of the log, I can't divide by log because it's a function. I need to do the opposite of the function. The opposite of the function is the anti-log, or 10 to the x. So if I take 10 to the x of the log of something, then I just get the something. And then I do 10 to the power of the other side, and I get 10 to the negative pH. And that's where that equation comes from. And your calculator should have a 10 to the x button, not a times 10 to the x. It's not your scientific notation button, but a separate 10 to the x button. That's the anti-log button. So calculate the hydronium ion concentration for a solution with a pH of 8.37. So we need that equation. The hydronium ion concentration equals 10 to the negative pH. So that's 10 to the negative 8.37. We're not used to seeing 10 to the, without it being a whole number, right? But your calculator can handle this. So I'm going to use the 10 to the x button, and I'm going to put in negative 0.837, negative 8.37. And my calculator is showing me this. 1, 2, 3, 4, 5, 6, 7, 8. This number has two significant figures, and my calculator is only showing me one. What do I do? Well, the thing is, that is the limit of what my calculator can display. A lot of calculators will give you 9 decimal places, and they'll stop. If it's more than that, it'll put it into scientific notation and show you the rest of the number. So this is like a little glitch when your calculator. So there's a couple things you could do. You could multiply by 1,000 or something to move that decimal point over, or your calculator should be able to show this to you in scientific notation. So on mine, I have to go to Mode, and then over to SCI for scientific notation, and then I have to quit the mode, and if I press Enter again, I get the full number. It's actually 4.265 times 10 to the minus 9, which would be 4.3 times 10 to the minus 9. And that the concentration would be in molarity. Mm-hmm. So just watch out for that. If it just shows you one digit like that, say, no, give that to me in scientific notation. Questions? Well, there's pH. We can also do pOH, which is the negative log of the hydroxide ion concentration. And I'll derive this relationship quickly as well. So we know that hydronium ion concentration times hydroxide ion concentration is equal to 10 to the minus 14. 1 times 10 to the minus 14, right? If I take the logarithm of both sides, I get the log of H3O plus the log of hydroxide ion is equal to negative 14. If I multiply by negative 1, then this becomes positive. This is negative. It doesn't look very negative. That's a negative. And this is, didn't mean to do that. And this is negative. The negative log of the hydronium ion concentration is what? The pH. The negative log of the hydroxide ion concentration is the pOH. pH plus pOH equals 14. Calculate the hydroxide ion concentration for a solution with a pOH of 4.25. So I want the hydroxide ion concentration. Hydroxide ion concentration equals, I'm going to give you all those formulas on the periodic table sheet of the exam, so you go look up the equation. So hydroxide ion concentration is 10 to the minus pOH. So 10 to the negative 4.25. .6 times 10 to the minus 5. Any questions? So let me show you what I call the circle of pH. Just want a blank page. So there's relationships between all of these different things. So if we put pH at the top here, from pH we can calculate the hydronium ion concentration. From hydronium ion concentration we can calculate hydroxide ion concentration. From hydroxide ion concentration we can calculate pOH. And from pOH we can calculate the pH. I call this the circle of pH, like the circle of life. Those are double-headed arrows because you can go either way. And so the relationships here, pH is negative log of the hydronium ion concentration, or going the other way, hydronium ion concentration is equal to 10 to the negative pH. The relationship here is that the hydronium ion concentration times the hydroxide ion concentration is equal to 1 times 10 to the minus 14. Between pOH and OH, just like pH, but we're looking at different substances. And then this one's my favorite. pH plus pOH equals 14.